You don't have to say it. I can't remember.
What's up,
Legas? We're doing review for the open note quiz
On exponents.
on exponents.
Good job.
Thank you. Thank
Good seat.
Goodbye, Legas.
you. Goodbye, Legas.
All right, so I'm taking a couple of examples from the textbook and just kind of going in order. By the way, I also put all of the pages from that textbook that we've been working with, the textbook from last year. I just made a little file of all of the pages of the lessons from the textbook and I put it on Canvas. If anybody just wants to go through the actual textbook part, but these are just kind of like the notes from that. Okay, so we're gonna call this, and you're gonna write down everything that I'm writing down, okay? And you're gonna pay attention. Remember we talked about attentiveness today in assembly.
Yeah, I didn't understand anything.
Exponent.
It's blurry.
I know, I'm gonna fix it. It's trying to focus in on why is it doing that? It's just gotta pick up the writing. There we go. All right, exponent properties review. Now you can add stuff to this if you want. This is just all that I'm writing, but I'm going to write it as clearly as possible. So the first thing we're going to talk about is reviewing the zero as an exponent. Can somebody remind me of what the rule is if 0 is an exponent? Yep. Anything to the 0 power equals 1. Here's some examples. You can use these notes on your quiz tomorrow, so make sure you're paying attention. Why are we on our Chromebook? Thank you. Did you take any of these notes yet?
Yeah, in my.
No. All of it, I already said, everything that I'm writing today, you're writing. I'm going to be checking them tomorrow during the quiz. This is your homework. Your homework starts now. You better make sure you have all the notes that we do in class. And if I add any notes to it and put them on Canvas, you better get those too. Examples. Okay, so let's start something like super easy. 4 to the 0 power equals 1. 5.14 to the 0 power equals 1. What about negative 5.14 power? Negative 5.14 to the 0 power, if the negative is inside the parentheses, what is it? It's still 1, because the whole thing is to the 0 power. Now, this is an example of something that would make it not 1, it would make it negative 1. If you have the negative 5.14 to the 0 power, that means negative, or a negative 1, times 5.14 to the 0 power. 5.14 to the 0 power is what? Nope. 5.14 to the 0 power is 1. Then multiply that times a negative, and you get negative 1. So that's a little special example. And so we'll say, if the negative base is not in parentheses, then it will be negative 1. Because in order of operations, exponents comes before what? Multiplication, very good. Comes before multiplication. And I'll give you one more example. Negative 5 to the 0 power and negative 5 to the 0 power. It sounds like I just said the same thing. If you just listen, it sounds the same. Negative 5 to the 0 power, negative 5 to the 0 power. The difference is this guy has the negative inside the parentheses, so that means everything is being raised to the 0 power, which means the whole thing is 1. This guy, it has the 5 being raised to the 0 power, and the negative comes after raising it to the power. So that would cause it to be negative 1. Okay, so now we're going to talk about negative exponents. For example, 7 to the negative 3rd power. It's got a negative attitude, so it goes down to the basement or the dungeon. And so on the numerator we have a 1, in the denominator we still have 7 cubed, but it's positive now. It's getting a better attitude now that it's being sent to the basement. Can you guys see okay? Huh? Yeah, definitely. You can move over there. Yeah, you can move. Just careful with the camera. Can you see okay now? Can you boys see okay? You can move there. That'll make it easier. Can definitely see okay now? If your numerator is raised to a negative power, send it to the basement to get a positive attitude. Now, what if we have, let's say, 1 over 6 to the negative 2nd power? What would we do? Yeah, we would just send it upstairs to get a more positive attitude, and then you could simplify that. You could also simplify this as well. So, if the denominator is raised to a negative power, send it upstairs to get a positive attitude. Oh. anything you want to highlight or anything to make your notes easier for you to go through them during quiz? You can do that. You can do it now or later. Okay. All right. So another example of that would be this. A to the second power over, I'm sorry, a to the negative second power over b to the negative third power. What would we do in that situation? Yeah, we would switch them. So that would go downstairs to get a more positive attitude. And this would go upstairs to get a more positive attitude. What if we had a to the negative second power over b to the positive third power? What would happen?
It will be one over a to the second, b to the third.
Good. The a to the second would have to move downstairs to get a more positive attitude.
Maybe
The b cubed can stay where it is.
maybe its brother b cubed will talk it out with him.
That would be nice. Be a positive influence. Get it? A positive influence?
Oh my
Oh!
god, that joke was
Math jokes! Woohoo!
Folks.
Yep. Okay, and then I just wanted to point this one out because once your numerator is gone, you do need to replace that with a 1 so that you're showing that there is something in the numerator. Okay? Let's see.
If anyone on YouTube will not days from this just
My light out.
Let's do another example. Let's do a little more complicated one. 5a cubed b to the negative 2, no talking. So because I see a negative attitude here, something's gonna move, right? Are there things that are gonna stay?
Yes,
Yeah, what can stay?
5a cubed.
5a cubed. And then what has to move?
B to the negative second goes to the daisy.
Goes to the dungeon and becomes positive, right? 5a cubed over b squared. What about something like this? What can stay?
B to
No.
no, two.
The 2 can stay.
Yes,
This is
ma'am.
very important.
Because we can never remember.
This 2 is not part of the negative exponent. So it can stay in the noon. But one has to move. The a to the negative fourth will become a to the positive fourth in the denominator. And b to the 0 power is 1. So I can show that it's being multiplied times 1, or I can just leave it out, because it's an invisible multiplication of 1. And that's it. I don't know why I made my crafting bar so large.
Moving numerator.
Yep, I'm just shortening because it's such a big word.
I'm just. What are we talking?
Alright, so the next part we're gonna review is multiplying powers, whoops, multiplying powers with the same base. The rule is if you have the same base being multiplied, add the exponents. Did I press record on anything? I did. I'm always afraid that I didn't. It's working, right?
Yes, huh?
Okay, so an example of that, just a really simple example would be 3 to the 4th times 3 squared would be 3 to the 6, because 3 to the 4 plus 2 is 3 to 6. And some more examples would be, or another example is negative 5 to the negative 2nd times negative 5 to the 7th. Same bases, so negative 5. Add your exponents. Negative 2 plus 7, negative 5, continuing in parentheses. To the 5th power. If I were to simplify that, would my answer be negative or positive?
Positive.
Negative.
Why?
Because
Yep, because it's an odd exponent, which means there's gonna be an extra negative at the end. It's gonna turn it negative. All right, let's do another example of that. For z to the 5th times 9z to the negative 12. Now the 4 and the 9 are not being exponents. They are not being raised to these powers. Only the z's are being raised to the powers. So the 4 times the 9 can be done separately. 4 times 9, and then the z to the 5th times the z to the negative 12 would be times z to the 5th plus negative 12. 4 times 9 is 36. Then you have z to the negative 7th power. What would we do with that? Which part? Or all of it? Yep, just the z part. The 36 doesn't have anything to do with this exponent, so the 36 stays up top, and in the base, in the denominator, we have z to the positive 7. Next, we're going to talk about rational exponents. rational meaning fractional exponents. Comes from the word ratio. Okay. So, for example, if we have 81, the 1/4 tower, how do we write that? As a radical, which is like a root. The denominator is the root. And then to do it on your calculator, all you would do is punch in 81. Then we have to do the second function so that we get this guy right here. And then punch in your 4 for the root, and the answer is 3. And that's because 3 times 3 times 3 times 3 is 81. The denominator of your rational exponent is the root of the number. We good?
Yes, no. That's
On that same topic, but changing the fraction a little bit, let's do this as an example. 25 to the 3/2 power. So the denominator is still the root. But then the numerator is our exponent. The denominator is 2, so it's the square root. You can write the 2 here, but if it is a 2, then you also can leave it out. It's kind of like the invisible 2. Okay, so this would be the square root of 25, which is 5. Then we have to raise it to the 3rd power, and that would be 125. So the denom is the root, and the num is the exponent. Okay. All right, let's try something that looks really complicated, and we'll break it down. 2a 2/3 3b 1/4 times a 1/3 times b. Whoops. the voice to the 1/2. Now there's multiplication inside the parentheses, but if it's just multiplication and then these are being multiplied, it's really just multiplication overall. So you could rewrite this as just 2a to the 2/3 times 3b to the 1/4 times a to the 1/3 times 5b to the 1/2. It's the same thing. It's the same thing. Now what can I pull out because it doesn't have anything to do with the exponents?
2.
What can I pull out of this?
2.
Yep, our coefficients. So the 2, 3, and the 5 all can come out. 2 times 3 times 5. They can be added together. Then I'm going to look at my a terms. A times a, so that would be a to the 2/3 plus 1/3. And then my b terms would be b to the 1/4 plus I'm just waiting for you guys to fill in.
2.
B to the 1/4 plus 1/2. Now we're going to simplify. 2 times 3 is 6, times 5 is 30.
Yes, sir.
And then when we add these, we have common denominators. So 2 plus 1 is 3. 3 over 3 is 1. A to the first power is just A. Good. And then over here, we have 1/4 plus 1/2. You can rewrite that. 1/4 plus 1/2. Well, I was going to write it in parentheses, but that would change into 2/4. So 1/4 plus 2/4 equals 3/4. So that would be B to the 3/4 power. There are no negatives, so we can be done. Okay, the next one is power raised to a power. And the rule is multiply your exponents. For example, 5 to the 4th power to the 2nd power is what? Yep, 5 to the 4 times 2, which is 5 to the 8. And of course, we'll throw in a fraction there. X to the 1/2 power to the 3/5 power equals x to the 1/2 times 3/5 power, which would be x to the 3/10. I'm gonna let you guys, there's no moving. I'm gonna let you guys finish writing that quietly. Then I'm gonna let you guys pack up, but there are still a few more examples that I wanna put on here. And if you don't copy them tonight for homework, you won't have them tomorrow, okay? So make sure you guys all understand. Give me a nod if you hear me. There are going to be extra notes on Canvas tonight. I'll still have all these notes up, but then you'll see where this ends. There will be more continued, so you have to get those down in your notebook.